So first, I will start with an addition problem for radicals from lesson 4.4. I'll split the equation into 3 because before we do anything, we must simplify the equation. So I'll go over here to the far left and I will simplify 12, which is under the radical. And to do so, we write a factor tree. Two numbers that give me 12 is 6 and 2. I can circle the 2 because it's a prime number. Then I go to the 6. Two numbers that make up 6 is 3 and 2. I can go ahead and circle that, and I can go ahead and circle the 3 also. All right, so now we go up and we look at our index. Our index is not there at all, so that means it would be a 2. We automatically assume if there's no number there that it's a 2. So I'll go ahead and go back to my top. And so the index means that if there are two numbers that are the same, then those two numbers make one group. So I'll go ahead and circle my two numbers that are the same. All right, so my two numbers are 2. So if there's a pair, the pair goes on the outside of the radical. And if there is a one number that doesn't have a pair, then it stays on the inside of the radical. But before I can put the 2 on the outside of the radical, I must go back to my equation and look at the front of the original. There's a -3 on the outside of the radical, so I have to make sure I carry that outside number down to my simplified equation that I had got. So now my answer would be -3 times 2 radical 3. All right, so that was my first simplified part of the equation. All right, so we'll go to the middle of our equation, which is 3 radical 3. We don't need to simplify this part of the equation anymore lower because it's already been simplified down enough. So we can go ahead and bring that down at the end of my simplifying so it just stays the same as it is. But we can go over to the last one, which is 3 radical 20, which tells me that we do need to simplify our 20 that's under the radical. So two numbers that give me 20 is 5 and 4. I can circle the 5 because 5 is prime. For two numbers that make up 4 is 2 and 2. I can go ahead and circle the 2 2's because those are also prime. Now, I have to go up to my index. My index does not have a number, so I automatically assume that it is a 2. So now I can go and find my two numbers that are the same to make one group and make sure those numbers go on the outside of my radical, and the number that is still this that does not have a partner stays on the outside. But we must look in front of the original to see if there is a number, which there is, which is 3. So I go ahead and circle that, and I will go ahead and bring it down to my simplified equation. All right, so it'll be 3 times 2 radical 5. That would be my simplified half of the equation. Now that we simplified, I can go ahead and write down my simplified equation, which was -3 times 2 radical 3 plus 3 radical 3 plus 3 plus 2 radical 5. Now I have to multiply what's outside of the radicals. So I'll start with the -3 times 2. -3 times 2 gives me -6. I keep the radical, so it stays the same, which is radical 3. And then I just carry down this one because there's no outside to multiply, so I do plus 3 radical 3. And then I do 3 times 2, which gives me plus 6 radical 5. The radical 5 stays the same always because there's no way to distribute it. All right, So to combine radicals, I add the coefficients and keep the radical the same. So I'll just do, so I have to find the same radical that are alike, which is negative 6 radical 3 and plus 3 radical 3. I can combine these two because they have the same radical. So my answer would be negative 6 plus 3 will give us negative 3 radical 3. And then since this one over here doesn't have a partner to partner up into and add up, I just carry it down. So it'll be plus 6 radical 5. Now since I can no longer add these two because they are not alike, this will be my final answer. And this is how you add radicals. Now we're going to learn how to subtract radicals. Subtracting radicals is the same as adding. You can only combine like terms. Like terms, they have to have the same index and the same radicand, which is the number under the radical. The same rules apply. We still have to simplify. So I'm going to go ahead and cut my graph in half. Cut my equation in half. Straight down the middle. I'm going to simplify each side if needed to. 45 needs to be simplified, so I go ahead and make my factor tree. Two numbers that go into 45 is 9 and 5. I can go ahead and circle 5. Two numbers that make up 9 is 3 and 3. So those are my prime. I can go ahead and circle those 3 also. Now I look at my index. My index is a 2 because there is nothing there, so I assume that is a 2 again. So now I go down here, make sure I copy my 2 down because it was in an original equation. Now I have to look for 2 pairs that are the same to make one group, which are my 3's. So I know my 3 goes on the outside with the 2 up here, and my 5 goes on the inside of the radical. So now my simplified equation will be 2 times 3 radical 5. Now I can move on to the other side of my equation, which is 2 radical 5. I do not need to simplify 2 radical 5 because it's already been simplified enough. So now I can just go ahead and write my simplified equations down. So now I'm just going to rewrite my simplified equation, which was 3 times 2 radical 5. And it was also minus 2 radical 5. Now I can go ahead and multiply what's on the outside of the radical. So 3 times 2 gives me 6. I just carry down the radical, which is 5. And then I carry down the rest because there's nothing to multiply out here. Alright. So then now I can combine like terms because they both have the same radical, 5 and 5. So now I just have to add 6 and 2. My mistake. Subtract 6 and 2. So 6 minus 2 will be 4. And the radicals stay the same, so 4 radical 5. And that will be my final answer. So that is how you subtract radicals. Now we'll move on to multiplying radicals. Multiplying radicals is a little bit more difficult. There's more steps to it. The first steps are to multiply coefficients. Second, multiply what is in the radical. And third is to simplify. We can only multiply radicals if they have the same index. Alright, so our first step is to FOIL. So we'll go ahead and take 3 and then multiply it times 3. So 3 times 3. And then we'll also do it times negative 4 and radical 3. Negative 4 and radical 3. And then we'll also take the radical 3, put it right here, and still multiply it by these 2 again. So it'll be minus 3, or plus 3 radical 3. So now that we FOILed, we can go ahead and multiply. First we do 3 times 3. 3 times 3 gives us 9. Then we do 3 times negative 4 radical 3, which gives us negative 12 radical 3. The 3 does not affect the radical 3 because it isn't the like term of each other. So we just carry the radical 3 down. Next we do radical 3 times 3. Since they are not like terms to each other, we just put plus 3 radical 3. And then we go ahead and do radical 3 times negative 4 radical 3, which gives us negative 4 9 radical 9. So now that we have multiplied our equation out, we can go ahead and combine like terms. But before we combine like terms, we still have some things we can simplify in our equation, like negative 4 radical 9. When it comes to multiplying when it comes to multiplying, it's a little different than adding and subtracting radicals. This time, all you have to do for making the 9 a little bit more simpler in numbers is just squaring it if it can make a perfect square, in which this case it can. So 9 squared is just 3. And so I can just do negative 4 times 3 to make it a lot easier, and then carry down the rest of my equation. And now I can go ahead and start combining like terms. So 12 radical 3 and 3 radical 3. Negative 12 plus 3 gives me a negative 9. Negative 12 plus 3 gives me a negative 9. So I can carry down that radical, which is radical 3. And then I do negative 4 times 3, which gives me negative 12. Then I carry against this 9 plus 9. So these two 9s go away. Or actually, I do 9 minus 12. And that gives me a negative 3. And then it's minus 9 radical 3. And this will be my final answer because I can no longer continue because they are not like terms anymore. And this is how you multiply radicals.